Alright, so today we're looking at logarithm equations, okay? And the big thing, I know we talked about logarithms a little bit with when we did our transformations and stuff. The thing is, a log is just a different way to write an exponential, okay? It's just a rearranged exponential. There is a purpose behind using them. I'll tell you about them a little later. But the first thing you need to be able to do is just go back and forth between an exponential and a log. Okay, so the first thing, if you had an equation that looked like this, it said x equals b to the y power, okay, it is the same thing as saying log of b of x equals y. Okay, a couple ways I like to do that. First of all, I usually don't write it like this. I usually write it as b to the y equals x. And then I say that the big number becomes the little number and the other two switch sides. Okay? So the big number becomes the little number and the other two switch sides. The main thing you need to do is be able to write it back and forth. So if you go the other way, the little number becomes the big number and the other two switch sides. So looking at this, how can I rewrite log as an exponent? Again, the little 3 became a big 3, the 5 and the 243 switch sides. Or how do you go the other way from an exponent to a log? The big number becomes the little number, and the other two switch sides. Okay? So that's the whole first part of this lesson, is just rewriting from a log to an exponential. So you should take a second, look at those examples at the top, and see if you can do these before you check. But I'm not going to take much of a second, so I'm going to go ahead and do this. Again, the little number becomes the big number, the other two switch sides. That's the same thing. And you can kind of check yourself here a little bit, because you should know 15 squared is 225, and if I wrote anything else, it would not make sense. Same thing here. 3 to the negative 3 equals 1 over 27. 4 to the 5 halves equals 32. Going the other way. Log of the big number becomes the little number, and the other two switch sides. Same thing in the next one. Log 3 of 1 over 81 equals negative 4. Log of 1/7 of 1 over 343 equals 3. That's a pretty lame question. I would say be sure that I can tell a difference between the size of your little number and the size of your big number. I don't even know why I didn't finish this one. That's one thing I would point out. Same thing here, log 7 of 1 over 49 equals negative 2. Log 2 of 512 equals 9. Log 64 of 16 equals 2/3. Pretty easy. Down here, we are going to use that idea to solve some log equations. Okay, so the first thing you want to do is I usually go ahead and say that this equals x, because x is what I'm looking for. Then I rewrite it where it's not a log anymore. So this says 4 to the what power equals 64. Again, this is where knowing these numbers on this chart are going to come in handy. Okay, 4 to the what power is 64. You should know that that is 3. Same thing here. 2 to the what power equals 64. That's x equals 6. If you're not sure, you may have to do some guess and checking. So 100 to the what power equals 100,000. Okay. Well, if you square 100, right, then that is just 10,000. Which isn't 100,000, right? That's only 1, 2, 3, 4 zeros and not all 5. So you may have to do a little bit of fractions, okay? For example, here I may have to say, well, I need to take the square root of 100 first and get that to 10, and then I can do 10 to the 1, 2, 3, 4, 5th power. If you're not sure, you should check it out. Same thing here, 5 to the what power equals 625. That's actually x equals 4. Here's another one, 27 to the what power equals 81. Well, I can't go straight from a 27 to an 81. I need to first take the cube root of 27, get it down to a 3, and then do 3 to the 4th power to equal 81. What about this one? This is a good one. 25 to the what power equals 5. I need to take the square root of 25, and then that's it. 2 to the what power equals 1 over 128. Okay, well, since it's 1 over something, okay, I know that I need to have a negative. And then 2 to the what power is 128. That's actually 2 to the 7th. You may or may not know that one. You probably will before the end of this unit's over. So this is something important to kind of point out. When the number gets bigger, right, you're going to have an exponent that's bigger than 1, even if it's a fraction. Okay? When the number gets smaller, you're going to have a fractional exponent. When the number becomes a fraction, you're going to have a negative exponent. So this is something that'll help you out a little bit if you catch on to that right there. Okay? For this next one, I recommend changing that to a fraction. I don't really want to do it, but 10 to the what power equals 1 over. So if this has 1, 2, 3, 4, the decimal needs to move 5 times, so that should be 1, 2, 3, 4, 5 zeros. You might double check me because sometimes I get a little distracted with all my zeros. 5 zeros. 1, 2, 3, 4, 5. Okay, just checking. Good. What would I need to do to that? Well, again, since that's a fraction, I know it's going to be negative. Again, I have 5 zeros, so negative 5. I'm double checking myself. That's embarrassing. Okay, good. I feel good about it. 4 to the what power equals 1 over 32. Well, again, this is when I can't go straight from 4 to 32. I need to first break the 4 down. Well, first of all, to be honest, I know it's negative because that's a fraction. Then I need to break the 4 down by taking the square root of 4 and getting that to 2. 2 to the 5th power is 32, and that's how I get 1 over 32. Cool. On the back, we are looking at graphing logarithms, okay? So I don't know how much you remember about graphing logarithms, but the best way I could teach you to do this, I think, is first of all rewriting the exponential. So for example here, this, ignoring the 4, if I just had log 2 of x, I can rewrite that as 2 to the y power equals x, okay? So the first thing I would do is I would write down my table for 2 to the x power equals y, because we've done that before. So that's what I'm going to do first. We like to do negative 1, 0, 1, and 2. That's 1/2, that's 1, that's 2, that's 4, okay? But this is not the same as this, okay? To get this, I need to flip my table. So this is going to be 1/2, 1, 2, 4. This is going to be negative 1, 0, 1, and 2. Okay? So I use this only to figure out this. After that, then I can do my other transformations, like this one has a stretch. So I multiply all those values by 4, get negative 4, 0, 4, and 8. And then I can plot my points. So at 1/2, I'm at negative 4. And if you look, this graph is counting by 5s, which I think is stupid, but it's okay. At 1, you're still at 0. At 2, you're at 4. So again, oh man, this is again, I'm going to pretend like this is back to 1s. 1, sorry, 2. So this is 1, this is 2. This is 2. That's stupid. 1, 2, 3, 4. Okay. Sorry if that's confusing you. At 2, it's at 4. So 2, it's at 1, 2, 3, 4. And I can't do the other one. So it looks like this. The reason they did that is because you need to know that the log graph keeps curving out, and I don't really have room for that if I count this like it normally is. Okay. So for your domain here, remember that your domain switches from the exponential. X is greater than 0. Your range is y is all real numbers. Okay, I can go up and down, but I can only be greater than 0 on my domain. Again, this, like the last one, this one has an asymptote, but it's the y-axis this time. We'll talk more about what asymptotes are a little later. Okay, so I would do the same thing here on the next one. The first thing, I would rewrite this log. I have log 3. of x. So that is actually 3 to the y power equals x. Well, I can't necessarily do that, but I can do this. And we have done this. -1, 0, 1, and 2. So this is going to be 1/3, 1, 3, 9. Again, flip it for what you actually have. So that's 1/3, 1, 3, and 9. -1, 0, 1, and 2. These two functions, if you remember, are inverses of each other. I don't know if you remember that word. After that, I'm going to do my normal transformations. I'm going to have to multiply all these by 4. I don't know what their deal is with 4. And I'm going to, look what I just did. 9, 2, no, I'm good. I'm good. Okay, good. Whew, thought I'd lost my mind. And I'm going to have to move this to the left 1. Okay, so that's what I'm going to do. Here's 1/3, -1, 2, 3, 4, and I move it left 1. Okay, here's 1, 0. So 1 is still at 0, but I move it left 1. 3 is at 4, so 1, 2, 3 is at 1, 2, 3, 4. I move it left 1. I can't have room for the other one. Okay, domain on this one, because I moved it left 1, is going to be x is greater than -1. Range is still all real numbers. I'm not going to finish the last one. We don't have too many of these that you have to do.